Hello fellow keyboard samurai, this is Shadow here. Got a great video for you today about reverse engineering. This is take 2 because we had a problem with the audio on the first video. So to recap, we're going to be taking apart a Keygen, an Adobe CS6 Keygen, which by the way is notorious for having keyloggers and viruses and malware attached to them unbeknownst to the Windows users. We're going to be working with a Windows version of the crack today. There is an OS X version, and this is quite old, but I chose this specifically for the purposes of it being on databases so we can research it a little bit to get you going in the right direction. So the first thing that we're going to take a look at here is the Adobe Keygen strings. Now if you watch some of my videos before, you'll notice that I did use the strings function here to show the ASCII representations of readable text. So that's the first thing that we're going to do. So we're going to type strings, and we're going to output the strings there to a file. So I'm going to say XF here, and we're going to output that to the strings file. As we do that, we see it pop up over here. We'll open that here with our text editor and take a look at some of the strings here. And as we see, this is just the readable ASCII representations of the hexadecimal values of the program. And at the bottom is what we're most interested in. Kernel, GDI, user, and WinMM. Kernel, of course, is the Windows kernel. GDI handles graphics functions, and user32 handles user functions, and WinMM DLL for Windows handles MIDI or sound or whatnot. And some interesting things we're looking at here is load library A, get process. You know, there's some things here that shouldn't be here, and I've been doing this for quite some time, so I understand that when I see certain things like this, that I already know that there's something in here that shouldn't be. But let's assume for the moment that you don't know, okay, as you are just learning. Okay, so we'll close this. The next thing that I want to do, this is step 2, is we're going to do an object dump. And this is disassembling the program so we can view the assembly language, and we'll output that to dump. So we can look at it in our text editor also. So as we bring that up, we can see all of the instructions in assembly language that this program attempts to execute. Okay. What you want to look for in things in assembly language like this are sequences like this. Now I already know, looking at this, that something like this shouldn't be there. It's just a repetitive calls and adds and whatnot. As we scroll up, we can see a bunch of other repetitive calls that shouldn't be there. And as you do this, the more often you'll see comparisons in a lot of the disassembled code that you look at, because a lot of the functions in Windows have the same address space. So you're going to call them, or address, entry point address, should I say. But as you see a lot of these repetitious things, you'll notice. Okay. Now this can be a bit daunting when you look at it the first time, but don't be discouraged, because they'll get better. And as you see here, another sequence of SBB and LCall, SBB, LCall, alternating, and then of course add increment, add increment. Okay, so I already know this, so going on to the next step, if this were just me, I could stop right here because I already know what's going on here just by looking at the assembly, because I write a lot of shellcode, so I already know. So we're going to close this, and we're going to go ahead to another step, and we're going to take a look at Anubis. Anubis, of course, a malware analysis tool. What it allows you to do is upload a binary, an executable file, and have it run in a sandboxed Windows environment. And it allows you to get an output of everything that it's doing. Okay, so we've uploaded this already. The general information about the executable, the name, where it was executed, and the load time and runtime DLLs. Those are some of the most important things, because we can get an idea of what it's trying to do. So we got the kernel, we got some graphics functions, and we got some user functions, some sound functions, and then some other things that we didn't see in our data dump or our disassembly. Okay. So secure32, and when I see things like this in combinations such as user32 and then secure32, I already know that we got some issues here. Ironically enough, this system says that there's no threats that could be detected by Anubis, and this doesn't imply that the execution of the executable is safe, just so you know, so don't rely completely on this. Okay, so I already see this, and it also gives you a nice little screenshot of the actual application running in this sandboxed environment. Okay, so we'll go back here and we see the registry values here, HKey local machine, HKey user, things like that shouldn't be being accessed if you're simply running a Keygen. This should be just making a couple simple calls for output to the terminal, or output to standard out or something like that in programmese terminology. And you'll notice too the file system controllers are accessing C program files, common files, and then the devices and the memory maps. And if you need to know what memory mapped files are and things like that, just Google them and look them up. It's outside the purview of this tutorial or this video. Okay, so we know that. We see that Anubis didn't find anything. The next step I want to do here is something that's interesting here that will illustrate exactly, pointing us in the right direction of what we want to look for. So I have a really nice Bitdefender installed here for the Unix version, and we're going to scan the local directory here. And as we wait for the plugins to load, understand that this could also be a false positive. When you're doing this kind of work and you're doing reverse engineering, you may get false positives. That means the things that look like viruses but are not viruses. Okay. In this case, what we're going to look at here is this infected file that's called application.keygen.ej, and if we research that, we're going to find out exactly what that is. Then the final step, once we look at that, is we're going to go ahead and type the file name here into malware, M-A-L-W-R, and we're going to see if we can find anything about the analysis. Okay? And this is one of the most important things when you bring this up, because this is a great resource. If you take a look at everything, it gives you every kind of piece of information about this file. It's already been researched. It was started in 2014, completed in 2014, and it also gives us the shellcode here. So if you want to get an account here and log in and get the shellcode, you will be able to match that shellcode up to our dump file. Okay, when we disassemble that, you'll be able to match this up and create a shellcode payload. So that's something that you, for those of you who are interested in shellcode, can do. All of these instructions equal shellcode equals a payload, and this is how a lot of things happen to create some of the more advanced payloads to exploit systems. So we're going to go to the static analysis and look at the strings, and if that doesn't look familiar, I don't know what is. This is something that we just ran, okay, on strings for this program, and you'll notice a lot of the calls here to library functions. So we'll go down to antivirus real quick and look, and you see micro-world escan defines this as application keygen, much the same way as our BD-scan did. So we know that we're on the right track here. And also take note that not all virus scanners are going to find this. This basically defines this virus by matching the shellcode bytes. So it matches shellcode patterns in order to determine whether it's a virus or not. In this case, I know it is because I've done this. But if we look at the behavioral analysis, this is the most important part. And malware.com allows us a really nice layout of everything in this program that it's running in sequence. So we can see green, it's network, orange file system, pink registry, blue process. So anytime we see a blue, we know this is going to be a process, and we can see the function call here, ZW map, and then of course create mutant, things like that. We're going to go to page 2 because I want to show you something pretty interesting when we're analyzing this file, is that we see a lot of registry activity here. So we're open in the key, and this is the status of that call. Okay, and this is where we have the problem right here. So we have nt create file, and you'll notice that the status failed. Okay, but as we scroll down a little bit further, we see nt create file, in the system directory. So see Windows System 32 wdmod.drv, and we see the return value. And if you're a programmer, you know what return values are. It means return status 0, which means everything executed okay. Usually if you have a return status 1, you mean a problem. I mean, Linux users, you'll be familiar with that when you try to compile things and you get status 1 when you try to compile. That means, failure, problems, Houston, we have an issue. So we see this creating a file, and right there I can stop. I don't even have to go any further. And there's 9 pages that this program, 9 or so pages that this program is going to execute. See, device I/O control, things like that, registry information file, and we can also check the network analysis to see if it's sending anything out over the internet, which in this case it isn't, and any dropped files, and a quick overview. So we've taken this file. It's a Keygen for Adobe CS6. We've decompiled it. We've looked at the assembly code. We've matched some patterns. We've matched some signatures, and we illustrated the issue and problem with what this may be doing. The next thing that I want to point out here is, just take a look here too. This is assembly, a text, R data, data, and R source. So these are all assembly entry points. So you have to remember, if you write assembly, for those of you who are writing assembly, you'll understand what these 4 things mean. Now, the imports, these are all of the calls to the functions in the libraries, in the dynamic link libraries that this program executes. And the one thing that I want to mention for everybody is the write file. So there's a write file call in here somewhere, and we're going to try to find it, which is right here. And I already know this is bad, so we're going to click on this, and we can actually see what write file function does. So what the write file function does in Windows is writes data to a file and starts writing data to the file at the position indicated by the file pointer after the write operation has been. So it also has a handle. It also has, these are the parameters to which this function takes, an LPD, and if you LP number of bytes written, things like that. So it puts information into a file at a pointer number, at a position into a file. So that's something that we want. We definitely don't want. And you can see all these other commands. For instance, sleep. We don't need sleep if we're just simply generating a Keygen. The second part, I think, that I might want to design, it's a simple program that just generates a random code to show you all the stuff that it should be doing, and you should see a lot less if we're simply writing a code generator. So we see all these things and research each one of these, because each one of these function calls here is resident in the kernel DLL in Windows, kernel 32.dll. Okay, so that's that. So we already know what this is doing. We've seen it drop files. We've seen the behavior. We've seen what it's trying to do, write the files, and here it's trying to execute buffers. It's trying to execute some code here as a payload, and we can take that to a step further to see exactly what this is doing. But there's really no point. We know what it's doing now, and NT query value name. So we've already know this is the file name that it's trying to write, and that would be that. So this is Shadow saying, I hope this works out. Enjoy. Don't get in too much trouble. Later, guys.